guys, welcome to the Tech Granth. Today we are going to solve the problem of largest rectangle in histogram. Do like, subscribe and share the video. Subscribe to the channel to get further notification. So the problem is given a non-negative integer representing the histogram's bar where we have the width of each bar is 1. Find the area of the largest rectangle in the histogram. So we have an input array like this, and each of the element of the array, it represents the height of the bar. So as we can see from here, the largest rectangle can be found by this tower 5, and it will be of area 5 into 2 because each bar has width of 1 as given here. So this 5 covers 2 bars, so basically width is 2, so the maximum area here is 10. So before going forward and understanding the tactic how we can approach this problem, let us see some of the cases. So we can have a histogram like this, which is nothing but this histogram. We can have something like this where the rectangle, the largest rectangle is found by this horizontal rectangle. The largest area basically is under this horizontal rectangle. We can have something like this where we have a gap here, and then this forms the maximum area under the rectangle of this histogram. And we also can have cases where we have like the single bar itself forms the maximum area. Let me show you one more example. I just copied it from Google. So it can be something like this where the maximum area comes from this horizontal rectangle which starts and ends at the starting and end point of the histogram bar. So like you saw in these example, you would see that you have to traverse the whole array list to get the complete area, and you need to move forward and backwards to get the value of the histogram and to find the area under that particular histogram. So the approach in this case or in similar case where we have to solve similar kind of problem is to take a stack basically. So you can simply put your elements in the stack, and as and when required you can pop out and apply some formula to get the area under the histogram or to compute any other stats where you have a similar kind of problem. So the formula here we are going to use will be, we need to get the height of the bar basically, and then we need to multiply it by some factor. Like for this particular answer you multiplied it by 2 to get the answer because this is the biggest rectangle. So let me share that formula with you. So the formula that we are going to work with is something like this, where every time we encounter a bar from this histogram we push it into the stack. So when we have to calculate the area we will pop from the stack that we are going to get, and here you see height. So this, I'm assuming that height is the name of this input array that we are getting. So the formula will be, you get the height of the element for which you have to calculate the area, you get the previous index. So previous index is, why we need previous index is because suppose I reached here and then I need to calculate, I reached 1, this starts from 0, 0th element, and I have reached 1, but I need to calculate the area of 0th element first. So in that case I need the previous this previous index, and the formula for getting previous index is this: if we have anything in this stack we will take the previous index as -1, otherwise whatever we have pushed in the stack will pick it up. So this will be more clearer once I go through this through the example of this histogram, how we are pushing and popping out from the stack. It will be more clear how this previous index and current height is getting used. And one thing you should observe is that we are not actually pushing the element of this array, rather than we will push the position of all these array, like the 0th position, ith position, means 1 position, 2 and ith position, and so on. So we'll do that, and the area will be calculated as the current height which we are getting here, whatever height is this one, into the I minus previous index minus 1. So it will be basically, suppose I have reached 2, so I need to calculate the area of the histogram, everything before this. So if I is equals to 4, so in this particular case I will be 4, so the area under 6 will be 6 into I is 4, 4 minus the previous index which is 3, and sorry, in this case it will be 2 and then minus 1, so it will be 6 into 4 minus 2 minus 1, so which turns out to be 1. So area under this 6 will be 1. How it will be, let me just scroll down and go through each of the index value. So when I start my process, the area will be when I is equals to 0, when I started, so that time my stack will be empty. The previous index will be minus 1, because I'm putting the formula stack, if stack is empty I'll use previous index as minus 1, otherwise we'll peek from the stack. So in this case, previous index will be minus 1 and I won't do anything. I just push the 0th element in the stack. So here I'm not pushing the element corresponding to the 0th element, rather than I'll just push that index. I'll push this I position here. Okay, and I'll move forward. So I'll go to the first position now. So when I is equals to 1, in that case what I will do is I will peek this position and I will see whether the height of this position is less than or equal to the previous one. Okay, so the current height is less than, if the current height of this bar is less than the previous bar, in that case we can pop from this particular stack, otherwise we will keep on adding. So in this particular case, since ith position, the first position when I is equals to 1, this bar is smaller than the bar at position 0, so we will pop that and we'll get it as the height. So here the current height will be height of the element which is there in the stack, so height of 0, and the height of 0th position here is 2. So current height will be 2 for us. Now once I popped this stack will become empty. So the previous index, here again this previous index will be minus 1 for us. So previous index is minus 1 and we'll apply this formula which says current height into I minus previous index minus 1. So the area here will be, when we apply the formula, 2 into I, where I is 1 for us, previous index is minus 1 and minus 1. So this turns out to be 2, and which is nothing but area under the first bar that we are getting. So the area under first bar is 2. So this area we can store as maximum area, because till now the maximum area whatever we have will be 0, and after that we will push the first element, not the first element, sorry, the first index into the stack. And then we go on to increment our I, will go to I equal to 2. Now here I equal to 2, the bar is bigger than my I equal to 1, which is the previous bar. So I'll just do this check, height of 2 is greater than height of, I'll peek from here. So it is greater, so I'll just push 2 into the stack and I'll move ahead. When I come to I equal to 3, my stack has 1 and 2, and I'll again do the same check. I'll say height of 3 is greater than height of the stack peak, which is the height of 2 basically. So height of 2 is 5, height of 3 is 6. So 6 is greater than 3, so we'll again just push 3 into the stack and move forward. When we come to I equal to 4, so our stack is 1, 2, 3. Now 4 is the height of I equal to 4 is less than the previous one. So in this case again what we'll do is we'll pop from the stack the previous index. In this particular case, when I popped it, the previous the stack will have 1 and 2, and previous index will be this element 2. So the area will be 6 into 4 minus 2 minus 1, which I was showing here some time back. And this 6 denotes nothing but the area under this histogram, this single bar that we have. Now again we will repeat the same loop, like we need to pop from the stack till we have the condition where the bar at the ith position, which is 4, is greater than the bar that corresponds to the element of the stack. So since the bar at this second element, this equal to 2, I equal to 2, which is nothing but 5, is still greater than the bar at 4, so we'll repeat this process. So we'll just pop it from the stack. So now the height of stack pop, which is nothing but the height of 2, height of 2 will be 5, this will be height of 2, and previous index now in my case will be 1 because I have popped from this stack. So this stack had initially 1 and 2 and I popped 2 from it here. So this stack has now 1. So this stack is not empty, it contains 1. So this previous index value is equal to 1. So now the area will be 5 into 4, which is ith position. We are still at position I, which is I equal to 4. The previous index is -1 and -1. We are doing this additional -1 is that's because I don't want to consider the bar at 2. We are calculating the area which is behind 2, all the area that corresponds to the element which is behind 2, or the ith position basically. So this turns out to be 10. So finally we will put compare whether the current area is greater than the max area that we have. If it is greater, then we will replace it with 10. Okay, so now we are left with 1 here in our stack. So the bar at position 1 is 1, which is less than the bar at 2. So I will not pop this one and I will move forward. So before moving forward, I will simply add this 4, this I equal to 4 in my stack. So now my stack will have 4 and 1, these two elements, and I reach I equal to 5. So when I reach I equal to 5, we have the stack with 1 and 4, and again the same comparison we need to do, height of 5 which is greater. So height of 5 is greater than height of 4, which is the last element count. So I will just add 5 into the stack. So now my stack has 5, 4 and 1. Then I will again increment my I'll go to 6. Now we have array till 5, I equal to 5. So I equal to 6, we don't have anything, so we will consider that the bar at 6 is 0 for I equal to 6. So now since that bar is 0, it is greater than the bar at 5, so I will pop 5. So the value at 5 is 3. So the current height becomes 3, previous index becomes, since I have popped 5 from here, the previous index becomes 4, and the area becomes 3 into 6 minus 4 minus 1, which is 3. Now this is not greater than my current max area, because my current max area till now was this 10. So I can just ignore this, and again the bar at 4, which is 2. So this bar is less than the bar that I have got at I equal to 6, which is 0. So I will again apply the same formula. I will pop the stack and I will calculate the area. Now this 8 comes as 6 minus 1 into 2. So basically this 8 is the area if this 2 formed the complete rectangle here, starting from 5. If you see, if from 5 till 3 everything with height 2, so there are 4 blocks, 1 2 3 4, and each of height 2, so the area becomes 8. Basically that is the area coming here. And finally the last element is of height 1, so this will be popped, and this denotes the complete area of height 1, but it covers everything from here, from the first bar to the last bar. This is the minimum one which is present for us. So this gives area as 6 for us. 6 is coming from when you traverse everything from 0th position to 5th position, and height is 1, so it is 6 into 1, which is the area is 1. And finally the max area that came was 10 for us, which came from this 5 in this particular case. Okay, I hope this is very clear. It is pretty straightforward. The only thing is when to pop your stack, and every time you move forward you push that ith position in the stack. So we'll just go through the code once. I'll start writing the code. So we will say int will keep a max which is 0, and in the end we'll return max. We'll have an area equal to 0, we'll have int I equal to 0, and we'll say for I equal to 0, I less than this height. We will say I less than equal to this height dot length, because we need to go to one ith position more than the length of the stack, where we will say that the last height is 0, the last height of the bar is 0, and we'll do I plus plus. Okay, so once this is done, so we'll say from here we need to get the as per this formula we need to get the current height, but before current height we need to get the height of each bar. So height of each bar will be, if I is equal to heights dot length, which is the one in the end. So if this is the case, then height will be 0, otherwise it will be height of the individual bar. Okay, and then we'll put a condition if the, and yeah, we need to define one stack. So this is stack of integer stk is equals to new stack. We'll say while stack is not is empty, and this h that we have, this h is less than, where is the formula that I was showing, this case where this height is less than or greater than. In this case we can just reverse it. If it is greater, we'll just continue. If it is less than, then we will start popping. So if h is less than this height, and we'll say stk dot peak. So basically if this is less than this, then we'll start popping from the stack till it is less. So when I reached here, I will pop till I have reached 1, which was the scenario where I equal to 4 scenario. Basically when I reached here, I popped it till only 1 was left in my stack. So in this particular case, I need my current height. Current height is equals to, so my current height will come from this formula, the initial formula. So it will come from height and will pop the stack. So we'll say current height equal to stk dot pop, and we need previous index, and previous index will again be this formula. If stack is empty, then -1, otherwise we peak. So we say stk dot is empty. If this is empty, then -1, otherwise stk dot peak. Okay, and then we have int area. So area is equals to this formula, current height into I minus previous index -1. So this is current index into I minus the previous index and -1. Okay, so here we have calculated the area, and we will say max is equals to math dot max of max comma area. So if this current area that I have calculated is greater than my max area, then you replace my max area with the current area that I have calculated. Okay, and once I am out of this loop, so suppose I went first time, so if I am not doing, or maybe this scenario, like if stack was empty, or stack the height is greater than the previous height, like this case, so every time I just go up and I say stack dot push, and I push I, which is the ith element. Okay, so yeah, I think okay, so in this case it's 10, and we'll just submit. Okay, so it's success. It has executed it in 8 milliseconds, and yeah, that is how you use stack to get the maximum area under any histogram. And you can use this data structure stack to solve similar kind of problem like I told initially, where you have to move all the way towards the end of a given array, and then maybe you have to move back also to check whether the previous value is greater than or equal to, or anything, wherever you have to move back, because you know the functionality of stack, when you pop, it's like last in first out. So it really helps in solving problem like these. So thank you for watching the video. Subscribe to the channel. See you in the next problem. Bye.